Welcome back to our final installment of new material for this semester. Roughly what ties together everything that I'm going to do in this video is that in this video, I'm going to do a bunch of problems where I give you some information about the derivative of a function. I don't tell you anything about the original function, but then I ask you questions about the original function. And so you have to use your knowledge of how the derivative is connected to the original function in order to answer the questions. So here's a typical question for this section. I've given you here the derivative of f. And my question, based on the derivative of f, is to tell me all the same things that we've been asking the whole time, which is tell me where is f increasing and decreasing, and classify the critical numbers of f. Notably, I did not tell you f. And we do not need to find f in order to actually answer this question. In fact, here's the key observation. The first derivative test actually gives us all the information we need to answer this question. So, namely, what am I going to do? I'm just going to follow the first derivative test, even though I don't know f. Well, what would the first step be of the first derivative test? Well, it would be to take the derivative of f. Well, after we did that, we would be here. Because this problem has given us the derivative of f. So then what would I do after I had the derivative of f? Well, after I had the derivative of f, I would proceed to find the critical numbers, which I would do by setting the derivative equal to 0. This is the derivative, so I'm going to set that equal to 0. Now, they were nice and they gave it to me already factored. So, in fact, my critical numbers are x equals 3 and x equals minus 5. These are my critical numbers. So far, effectively, all this question has done over the questions that we talked about in the last video is it's made our life easier because we didn't have to take a derivative, they just gave us a derivative. Next up, we're supposed to make our derivative profile. And into our derivative profile, we're supposed to plug the test points that we pick out. So I'll pick out 0, 4, minus 6. And note, because in the first derivative test you plug these numbers into the derivative, I still don't need to know the original function. I only need to know the derivative. So f prime of 4, if I look at that, that'll be 9. F prime of 0, that'll be 45. And f prime of minus 6, that will be minus 9. Okay, so then I have to go ahead and write down the signs of these up here. So here it is negative. Here it is positive. Here it is positive. And so just like we've done in all the previous examples, I can now take that derivative profile and translate it into information about the original function. Namely, here, the function is decreasing. And then here it's increasing, and here it's increasing. Again, positive means increasing, negative means decreasing. So let's go ahead and classify our critical numbers. So what happened at x equals minus 5? Here, the function switched from being decreasing to increasing. So that is a local min. Now I'll go ahead and note, there's one piece of something we did in the previous examples that we cannot do here. Namely, we can't write down the y-coordinate of my critical points. And the reason why I can't write down the y-coordinate of the critical points is that I don't have the function f to plug into it. But I still know that whatever the y-coordinate of this point is, it's definitely a local min. What happens over here at x equals 3? Well, over here at x equals 3, something happens that we haven't seen happen very often, which is that the function doesn't actually switch. It's increasing on both sides. And remember, that means that, in fact, the graph has neither a local min nor a local max at 3. In fact, at the critical number 3, we have a kink. So, only one thing we have not done yet. which is to write down the intervals of increasing and decreasing. I'll make room to do that here. The decreasing piece is from minus infinity over to minus 5. Now, I could write two things for the increasing piece. I could write minus 5 to 3 and 3 to infinity. But if you remember what the graph of a kink looks like, it looks something like this. And so even though there's this flat tangent line in the middle, this graph's still actually increasing the whole time. So if you want, and this is what I would do, you can actually write that this function's increasing from minus 5 to infinity, and that will work. Okay, so here's a different way that I can give you information about the derivative of the function without telling you the original function. Namely, I can give you a graph of the derivative. And so you'll see there are a number of questions of this sort on the homework. Now, from this graph, I can ask you all of the same questions. But I want to remind you, and this is very important, we're not given a graph of f. We're given a graph of f prime. So we have to be careful when we look for things like what the critical numbers are. Now, your mind might jump to these points as being critical numbers, but those are not critical numbers. Why is that not a critical number? Isn't the tangent line horizontal there? And the answer is yes, the tangent line to the derivative is horizontal there. So what this really is this is a critical number of f prime. But I don't have to think about that. I'm not talking about f prime here. I'm talking about f. So what does a critical number of f look like in a graph of f prime? Well, that's not so hard to think about if you remember what does it mean to be a critical number. It means the derivative there is 0. So the critical numbers here actually are the zeros of the derivative. So the critical numbers in the graph of the derivative look like the zeros. What kind of critical number is this? Is this a local min, a local max, or a kink? The way I have to think about this is I have to think about what happens here at minus 3. Namely, at minus 3, the derivative switches from positive to negative. And if you think about what that means, the derivative switches from positive to negative. That means the function switches from increasing to decreasing. And remember, increasing to decreasing looks like this, upside down U. Which means this minus 3, it corresponds to a local max. How about minus 1? Well, at minus 1, the derivative switches from being negative to being positive, which means the function switches from being decreasing to being increasing. Okay. And switching from decreasing to increasing has to look like this, a right side up U. Okay, so this has to correspond to a local min. What about at 1? Well, at 1, the derivative switches from being positive to positive. So it doesn't really switch. That is to say, the original graph f, which I'm not looking at, but the original graph f is actually increasing on both sides of 1. Which means that the graph looks something like this, which means it's a kink. Now this might all be confusing, but let me show you that we can do all of this exactly the same way that we did previous questions, which is that we can make a derivative profile. And I'm going to mark off on my derivative profile all of the critical numbers. -3, -1, 1, 3, 5. And what was my goal with the derivative profile? I was supposed to say whether in each of these intervals the derivative was positive or negative. What is it over in this piece? Well, that's that piece. It is positive. Again, remember I'm looking at a graph of the derivative. So when I'm asking if the derivative is positive or negative on this graph, I'm just asking whether the derivative is above the x-axis or below the x-axis. So here it's positive. Here it's negative. Here it's positive. Here it's positive. Here it's negative. Here it's positive. And again, all I'm doing is looking at whether the graph of the derivative is above the x-axis or below the x-axis on each of these intervals. And just like before, I can translate all of these positives and negatives on the derivative to statements about where the function itself is increasing or decreasing. So increasing, decreasing, increasing, increasing, decreasing, increasing. And then, just like before, we can say, okay, -3 has this shape, that's a local max. -1 has this shape, that's a local min. 1 has this weird shape, that's a kink. Then you can go ahead and do 3. 3 has that shape, so it's a local max. And 5 has this shape, so it's a local min. I won't write this out, but if I were to write it out, it would say this function f is increasing from -infinity to -3. It's decreasing from -3 to -1. It's increasing from -1 to 3, decreasing from 3 to 5, and increasing from 5 to infinity, just like we did in all the previous examples. All right, this should leave you pretty well prepared to tackle all of the homework for 4.2. Which means that all I have left to do is to remind you that Text 6 is coming up on Friday, November 13th. It's going to cover Section 4.1 on the closed interval method and Section 4.2 on the first derivative test. So that's not that much material on the one hand, but on the other hand, doing the first derivative test and the closed interval method and interpreting these things from the graphs, these things require basically everything we've done for the entire semester. So in another way, these two sections alone are sort of a review for the final. Speaking of the final, which remember counts as 2 tests, will cover everything. That is, it is cumulative, and it will be on Friday, November 20th. It will follow the same format as the previous exams, although it will be longer. Now, when I say everything, that means everything we've done is on the table. So I will certainly ask you to do stuff with limits and calculating the definition of the derivative from a limit, all the things with tangent lines, basically everything we've done throughout the course. However, the way this course is set up, the first half of the course is all there to enable you to do the second half of the course. And so all the skills we learned in the first half will show up in questions about the second half, which means really the second half of the course will be emphasized more. So you should not have to spend that much time looking back at Chapter 1, for example. You should probably start studying by looking at Chapter 2 forward. Next week, I don't intend to post more videos, but I do intend to post one sample final each day, Monday, Tuesday, Wednesday, Thursday, and the homework for each of those days will be to do that day's sample final. And during the discussion when we meet, we'll talk about any questions you have from the sample final or any questions you have from the entire course. And so hopefully come Friday, you'll be very prepared. One note. A lot of people have gotten lots of extensions on tests and whatnot throughout the semester, and I've been happy to do that. However, for the final, By college policy, this is the last day I can give you the final. So if you need to take the final early, you can talk to me about that, and I'll see what I can do. However, I can't give you an extension beyond this, so you must take the final Friday. The November 20th Friday, to be clear, not by this coming Friday. All right. It's been a joy to have you all this unusual quarter, but I'll look forward to seeing you all around campus. Hopefully in a year or so, we might be walking around campus without masks. We'll see. Anyway, it's been a pleasure. And for those of you who are going to take 141 next semester, I'll see you all next time.